Like super great, right? I've had fun. The only thing that I dislike is that I have to choose one of 4 talks, which makes me feel bad because I want to go to all of them. Too bad we're only here for 2 days. All right. So I've got a URL at the top of this slide up here, which is the same URL that I'm on that screen. So if you want to see the same view, you can. It should follow along as I go through on my own. So today I'm going to be talking to you about the technology that you see in that GIF there on the first screen, where there's my friend Stanley writing on a steno machine. And you can see he's writing into the same box that's at the top of the window, and it's outputting text. So I've got a Skype call running on my laptop right now, and on the other side is an individual named Mirabai Knight. Mirabai's kind of a strange name, but it is her name, and she's a real person. So please don't ask her if she's speech recognition software, because she isn't. She's much more accurate than speech recognition software is right now. And she's typing into a website called Aloft. Aloft is a captioning website that was made by Stanley, the guy who's writing in the picture. You can see we're a very tight-knit bunch. All right, so now I'm going to get started. Me, I'm Ted. Ted Morin. Morin Ted on Twitter and GitHub. I'm from Canada, Ottawa, Ontario, and I'm currently finishing up my software engineering undergraduate at the University of Ottawa. I split my time between school and working for a high-tech medical startup called Clearwater Clinical. There I use JavaScript, mainly React and Redux, to build web applications for their products. I'm actually a really big fan of JavaScript, so all Pythonistas kind of hate me for that, but I don't hold it against you. I understand why Python is really great in its own way. I've used Python for what I consider a long time relative to my young age, but I've used it before Node was a thing, and so it was my first scripting language, my first language that I ran through a command line, and I used it for web scraping, little tasks, basically any sort of automation I did. I really liked it. I liked the duck typing. I like the named parameters. Best feature in any programming language. Use that all the time. So in my free time, I lead the development of an open source steno application called Plover. And I'm really lucky to work with people in the community who are smarter and more experienced than me, even especially with Python, and I've learned a lot from them. And I'm a software developer, clearly, and I use stenography and steno machines to program all my code. Steno machine, what's a steno machine? I've got a few up there. I have a few up here too in person that you can see. They kind of look like computer keyboards, at least in size, but maybe more like a piano or a musical keyboard. And that's definitely a little bit more how they play. So instead of hitting in individual keys to make a word come out, where you're spelling every single letter in order, instead you form your hands into a shape and push down on the machine and hit all the keys at once. And then when you release, that forms a chord, and the software outputs words. And this is what you see at the top of the screen right now. You can see every word comes out in one unit. And that's because Mirabai is chording her hands into make these words and little phrases. If I say of the should come out at the same time rather than individually, because common phrases are held together. So if I go of the, you'll see it comes out at the same time. It's really cool because you can kind of get some kind of, you can, all right, you can get some really long words out, like supercalifragilisticexpialidocious, with just one stroke. And you can basically apply that to anything. Instead of having a bunch of aliases in my bash RC, I have steno strokes that I can bring with me. So I've known about stenography for 2 years now, and I'm really excited to get a chance to share it with you guys today, especially if this is your first time hearing about it or seeing it in action. So stenography allows people to write on a computer over 225 words per minute, which is on par with human speech. And I'm here right now because Plover, the first free steno software, is written in Python. So before I get into the nitty-gritty of it, I'm actually going to show you a video so that you get a better understanding of what it looks like to write on a steno machine, because descriptions are only descriptions. I'm playing in this video a game that OpenSteno partnered with an accessibility video game company called For All to Play, and they partnered together and made Steno Arcade, which has a sub-game called Steno Hero, where you listen to songs and you type the lyrics in time with the singer to get a high score. So in my video, I'm writing on the Mac keyboard and the QWERTY layout, as well as my Trial Steno machine. And I recorded myself playing the song twice to get an idea to show the difference in hand effort. Pay attention to my fingers as the music is coming out, as well as the text output. Neither run was perfect. I was a little nervous and I didn't do very well, but you can still get a big idea of the difference between the two. So on the left, I'm not using any proper method to touch type. I'm not that good at QWERTY. I was just self-taught as a kid, and so my left hand, I'm left-handed, does a lot more work. And you can see that my hands are moving all over the keyboard, left and right. I'm falling behind. I was probably letting out a few expletives while doing the work. So on the right side, I've got the steno machine going, and you can tell that this is much slower than I'm capable of with the steno machine. I'm relaxing between words, just letting it out, waiting for the singer to let his words out, because I can see the text coming up. So there's a huge difference. Maybe now, is it clear to everyone how it looks to write on a steno machine? Awesome. I've done this talk before, and that's the hardest visual to get across. So my goal today is to tell you about Plover, open source steno software written in Python. To do that, I need to define what stenography is and why its speed is so useful. I'll be able to convey in simple terms a little bit of the mental process that a stenographer has to go through when processing language. And I'm going to do that in a method that I like to call thinking with portals. We'll go over how Plover and OpenSteno came to be, and then talk a little bit about the Python program behind it. Finally, I'll close with some thoughts about where I think steno will go in the future. All right, so stenography is a system of writing that aims to decrease the amount of effort required to express language. You may have heard of common written stenography, written shorthand, like there's systems like Gregorian or Pitman, which court reporters used to use before steno machines existed to take down notes, as well as journalists before they typed everything or recorded it. With the written stenography, you could take notes pretty quickly, and a lot of students learned it too. It was basically before typing, it was the only way to write at that sort of speed, 80 words per minute or so. The stenography that I'm more interested in is machine stenography, and it's actually based off the same phonetic principles as written stenography. It's a system that optimizes for English, mainly phonetically, in order to increase the output speed of transcription. With machine stenography in particular, the stenograph allows you to chord keys. That means that instead of writing out the letters, you just chord one word at a time, as you saw. Old steno machines, before there was instant output, you had ticker tapes that would come out. And so the stenographer would sit in the courtroom and write out on a typewriter-style steno machine. As this ticker tape fed out, every line is a stroke. And then when they were done, they would come back and review it, and they would look and transcribe it manually. You should be able to read these short words. It's a very manual process. You can tell, isn't Y-O-U, it's just the U key. Makes sense. It's phonetically based. English is very simple phonetically. It's not simple orthographically. Now, luckily in modern times, translation is instant, as you can see in the text above. So for the actual layout that I have up there, it works declaratively. You have 3 sections, which I've separated with color, but there's the left side, and you put your fingers on it, and it makes the beginning sound of the word. Then at the bottom, you have the thumb keys, and the thumb keys make the vowel sound. And then finally, the right fingers make the ending consonant sound. And so you're like, what? I know it. To write my name, Ted, you hit the T on the left side, the E as the thumb key, and the D with the right side, and you push them down all at once in any order, and then you let go, and Ted comes out. Super simple example, but it gets worse. You can see that there aren't a lot of keys here, only 22, and it doesn't cover all the letters. And you have some doubles, like 3 S keys. Really, the 2 on the left count as 1 key, so it's really only 2 S keys, 2 T's, 2 P's. And the reason is because you have a lot of words that start and end with T. You're thinking, all right, where's the M key? So you can start and end words with M, but to do that, we basically use chording, and we try to do things in a non-conflicting way. At least that's how it was made originally. So I'm going to say the L key, the L sound, can be made by hitting the H and R keys. And the reason that those 2 keys make L is because you don't have any HR words. You don't have any LH words. You don't have any RL words. And so it's non-conflicting generally, and you just make these shapes with your hands. It's actually really nice because there's only a home row in this layout. You don't move your hands around. It's always the home row. There's no wrong way to type in steno. It's the only way to type in steno. So, as I mentioned, English steno is phonetic. Not every steno system is phonetic. Some languages are pretty simple orthographically, and they'll use orthographic theories where you just compose the letters together. Russian, Spanish are examples of these languages that are pretty simple that way. English, though, spelling sucks. Definitely got a big problem there. I've got some examples here. Nauseous, cautious, conscious. Those all end in the same sound, but look at the spelling. They're completely different. Who thought that was a good idea? In steno, it is a good idea because it's just the sound, SHS, shush. There's a way to end in that with your right hand. And so when you're writing nauseous, I do na and shush. Cautious, ka and shush. Conscious, con-shush. Probably being awful to Mirabai here by not giving her real words. Sorry, Mirabai. So my next example is the word particular, and this isn't about the phonetics of particular, it's about the length of that word. That's a really long word, and it's pretty common. Particularly is particular with a suffix of ly, and that's 12 keys. And when you're typing at speed, let's say 80 words per minute, your hands are going in autopilot. If you mess up halfway through the word, it's really hard to backspace the correct number of times. So most people will just clear out the whole word. Maybe they have a control backspace for that. But in stenography, it's such a common word that we want to optimize for it. So in that declarative steno layout, you can fit the word plar. Plar is not a word. And so when you write plar on a steno machine, it comes out as particular. It naturally follows that a lot of words end in ly. So how do we do that? Why not use that ending L, plural? That could be particularly. So that comes up a lot where you have these sort of shortcuts that you go through and you start to learn these tricks to make your writing even faster. So altogether, the motto of the story, or the moral of the story here is that less hand movement, less finger movement, less letters, less everything means that you get a much higher speed of output. So you might be thinking, yeah, I don't know. I type pretty fast. Like, all my friends like to watch me type because they get impressed. It's not, not even on the same level as you can see from this chart. You have handwriting, which is real slow at 25 words per minute. If you're writing cursive, maybe. You've got hunting and pecking, which is what you might get from your father or from a novelist. And then you have touch typers, which I imagine a lot of people in this room are, or generally programmers can type pretty fast even if they look at the keyboard. I've seen people type over 100 words per minute with only 4 fingers. Terrifying. But I'd call the average around 80, and I don't think that's pessimistic. Next we have casual speech. This isn't casual, I'm rambling. When people talk normally, they're sitting around 160 words per minute, and that's way faster than most people type, so already there you have a big problem. Speech recognition software. This is interesting. A lot of people, that's the first thing that comes up when they see those captions is speech recognition software. So the one that's slated here, 180 words per minute, that's a trained speech speaker. Basically, they have a voice mask that they wear, and they sit in a place where they need to caption people, and they listen to everything that's said, and then they speak it back into the voice mask. And Dragon Naturally Speaking, or whatever software they're using, will process it. And so they need to have ways to deal with punctuation and line breaks, new paragraphs and symbols, and they end up speaking a language that doesn't quite sound like English. They're limited to about 180 to 200 words per minute, and the quality varies greatly in dealing with edge cases, like if you accidentally end up captioning a Python conference and you don't know any Python terms, it's not good. Finally, there's stenography, which is a bar ahead. That's 225 words per minute. That number comes from the NCRA's graduation speed. You need to complete a test and hit that speed in order to leave steno school and become a certified stenographer in the States. Which is where we are, if you didn't know. Okay, so that's not a speed limit either. The world record holder for writing in steno is Mark Kislingbury, who has a record of 360 words per minute. That's not to say that 80 words per minute is the limit of touch typing either. Sean Rona is the fastest typist in the world that I'm, well publicized. I'm sure that there are other people who are just really good too. But he can hit 200 words per minute when he's going at super speed. And it's insane if you watch the videos. But stenographers going at 225 words per minute, they have to do that every day. And they might have to do it for up to 8 or 10 hours. Like in WordCamp right now, where Mirabai's colleague, Stanley Sakai, and Norma Miller, they're both captioning the 2 rooms there, and they're doing that all day long, every single talk. So it's very fast, and you might think, how does it work? And this is my thinking with portals method that I like to reference. So when you're thinking with portals, you can look at that phrase and you see a few things. On the word think, the ing suffix, that's really common. With is a super common word. Let's replace that with W. Portals is plural. It's not really part of the word, so it's just an extra ending point. And luckily the steno machine ends in an S, so it's easy to make any word plural. From there, that third line is probably how I think of it mentally. Phonetically, I'd say in my mind, thi-ing with plurals. Because you can drop unstressed consonants and stuff, and that'll correspond to those actual keys, which is the, in caps is the representation of what it would look like, and then the layout you can see are the strokes that you'd make. And so even though thinking is 5 keys all at the same time, it's only 1 stroke, and that's just as difficult as only hitting 1 key. It's very simple to do, so you can write thinking with portals as fast as someone can say it. So you might think, what is steno good for? Clearly captioning. And why is captioning important? So a big reason that steno is important is because of accessibility purposes. 1 in 5 Americans report hearing loss. 1 in 3 above 65 years of age. And that's a huge issue, and a lot of people don't think about the fact that they're missing out on content. Or maybe someone's not aware that they have bad hearing, and so they're constantly missing words that people are saying. They don't know how big of a problem that is. And steno really helps alleviate that problem by giving someone captions so they can participate as well. Now, you're lucky right now because there are captions going on, so if I misspeak or speak too quietly or away from the microphone, Mirabai still gets it, and she's pretty good at catching it, so you can see what I said. But if she wasn't there, you wouldn't have that option, and most of the time she isn't. At conferences, or online, when a YouTube video gets uploaded, there are no captions. You get sent a cool friend from your video, cool video from your friend, and you can't understand it if you can't hear it. And so viral videos, there's a lot of the internet that people miss out on, and you're always looking for transcripts, and it's a pain when they're not there. So another place that it could be really useful is for people who don't speak. And so for various reasons, people don't or can't speak, and that means that they can't communicate in a conversation at a conversational pace. They can't hold another conversation with a human being in a normal way because they have to write out, maybe they're really fast at typing, 100 words per minute. It's still not enough to keep the flow of conversation. So if someone can't speak and has full motor skills with their hands, they could spend a couple years learning steno to get to a point that is already better than their QWERTY speed, and then eventually becomes good enough to have full conversations with people in real time. That could work with text-to-speech software, which has already been done. Sometimes Mirabai is really cool and goes around talking to people without talking. But you can also have real-time chats online that way. So accessibility purposes, they're definitely there, but also there are more selfish reasons too. Like, why do I do it? Double typing speed. I want to be the best on TypeRacer, and that's my only real reason to do steno. Also RSI concerns, people who are worried about overuse injury, which is definitely a real thing, and I've overworked myself and gotten my hands hurt before. And then also note-taking in school, very useful. I captioned a very slow-speaking professor when I was learning steno and was able to sell the notes to fellow students for, I just said $20 for the whole semester and I made $300, so it was good. And then also, I mentioned before chatting online. I really like chatting online with steno because you can just write out bursts of sentences as fast as you want to. There's no limit of thinking about like trying to get your point out and trying to write out the sentence, which I didn't realize was a huge issue until I was able to write as fast as I needed to. I mentioned at the beginning that I code in steno. And that's true. I work at my day job and I bring my steno machine and people are very impressed and don't laugh at me at all. Thank you. And it's not explicitly like, I'm not doubling my coding output because that's not how coding works. You have to think about your problem much more than you have to write about it. But there is something to be said about the comfort of writing comments. Steno handles its own spacing and capitalization automatically. You just set it up properly once and then it does it forever on its own. And so when I end a line in Java with a semicolon, it can automatically return for me as I go or make it pretty much do whatever I want. There are some videos of coding online in steno. That's one of them on the left. That's me writing a fizzbuzz in JavaScript. So if you go and look up that video, you'll just hear me talking through the problem, and you'll realize I'm writing kind of slowly because I'm describing my thought process, and that really shows that the stopper isn't my typing speed in that case. But for writing documentation, it comes in really useful to be able to just burst out sentences all at once. And then on the right is Mirabai copying some Plover source code, and she's a better stenographer than me, so maybe that looks a little faster. So I'm going to talk about what it would take for you to learn steno, but I'm going to pretend like it's 10 years ago. So steno used to be just a walled garden of expensive proprietary choices. I chose that sentence very carefully because I think it emphasizes everything that was wrong with it. To learn stenography, you need three things. You need hardware, you need software, and you need to learn it. You need learning resources. And just under a decade ago, all these three things were only available in super proprietary lockdown format. So I'm going to talk about the cost here. You have your hardware, which is a steno machine. You can get a student one, but often the school will sell it to you. You need software, which you can, it's really awful, but I'll get to that later. But anyways, the software is very much a walled garden. It only interfaces with the steno machine. And then you need to go to school, which is usually college. So your steno machine, $1,000 to $4,000 easily. Student machine, you might be able to go under $1,000, but you're not going to use it long and it's going to be replaced. The software is a couple $1,000s to purchase with an annual support license renewal of something in the neighborhood of $400, $500. And then finally, 1 to 7 years in college, because it's a very talent-based skill, kind of like if you went to school to learn piano, where you might find out, as most people do, it's just not for them. And so they spend lots of money and go to school and drop out. The dropout rate in stenography school is over 90%. Yeah. Yeah, and so, but think of if piano was the same way. If you had to buy a piano and go to school to start learning piano, no one would do that. And that's why you've never heard of stenography before, until now. So what if you started learning today or tomorrow? Well, there's Libra software, free as in freedom. There are free games, open community, free texts, and pretty cheap hardware. So let's see what changed. This is Mirabai Knight, and she is, as I mentioned, a geek, and I've collected some pictures as proof. It's her walking around with a steno machine and her with a Google Glass for captions. She graduated from a court reporting school in March 2007 and was fed up with the whole system. She had this technology that allowed her to express ideas in super speed and was unable to use it for anything else other than creating depositions, basically. You can read through back through the Plover blog all the way back to 2008 when Mirabai had decided that she would create Plover. She wanted an open source steno software system that solved all the problems that the other software didn't, but she couldn't code, which is a big stopper when you want to make a program. So an elevator ad and a little bit of chance and a dash of fate later, Mirabai actually met a freelance software engineer who had graduated from the MIT Media Lab who was willing to teach her Python. That's Joshua Lifton. He started to teach Mirabai Python, or rather, how to code. And then he discovered that she didn't want to learn how to code. She wanted to learn how to code one program. And so they started to work on it together. And then eventually, Mirabai decided that coding just wasn't up her avenue. And Josh became the first lead developer of Plover. And he made the first prototype. So Plover was born. These are plover birds, the kind you see hanging out in the mouths of crocodiles. You might think, why is the steno program called Plover? Well, the way you write Plover on a steno machine is actually the same way that you would write moreover. It's a conflict. That's what phonetic conflict in the machine. And moreover is a very court-y word. Your friends probably don't say, moreover, I was hanging out with her. It's more used in court situations. And so Mirabai wanted to give Plover that stroke so that she could say, this software is meant for everybody else, not the court people. But the court people can come along if they want, bring their own dictionaries. Fun little fact, this is Dolores, the mascot of Plover. Her name is Dolores because you can write that in one stroke and it's 3 syllables. Plover itself, you can see on her wing, she actually has a little steno machine, and the dark keys make out the stroke for Plover. And that's what the main interface looks like, which is pretty minimal. It doesn't get in your way because you're using a keyboard effectively. So Josh eventually left the project because he has a company, Crowd Supply. It's like a crowdfunding website that focuses on a high success rate in physical products. But before he left, he said, I'm going to make a Stenosaurus, which is a lower cost steno machine made for the every person. And it's going to be hundreds of dollars instead of thousands of dollars, even if it looks super pretty like these pictures you see. You can follow along the Stenosaurus blog to see how that project is going along. So after Josh left, there was no software developer. Is Plover dead in the water, set to be without a developer forever? Well, no, because then we had Hesky Fisher come along, and he's an engineer who works at Google. He made a really big push in Plover's feature set. He added lots of other steno machines that it could work with, and also made the cross-platform support so much better, ported it to Mac. And he brought it to a point where it was really usable software. So he released the last version 2 years ago, which most people who have tried the software have used at some point. And it was a really, really good version of Plover that Mirabai could actually use for her own job. So she switched from using her proprietary software to the free one for everything, which I think is pretty impressive considering that, you know, it's free as opposed to $4,000. Heskey eventually did stop working on Plover so much to focus on other projects. And there was a clear need for a new developer. And at first, I wasn't really interested because I'm not an MIT graduate. I'm not even an undergraduate. But last summer, I found myself taking on the torch of Plover's new lead dev. And Plover's at a pretty great place. And I just, you know, have pushed it further. We made our first release in 2 years in January, which was very fun. So the software is free. The hardware's getting freed. They're cheaper alternatives now. But what about learning it? And that's where Zach Brown comes in. And Zach is a technical writer. He has worked at Google and with the Linux Foundation. And he took interest in learning steno and reached out to Mirabai. In exchange for lessons on stenography, he was to document them and write a free textbook for anyone to learn steno. And that's turned into Learn Plover, which is a free online website that you can view and learn Plover with, as well as a Amazon on-demand book that you can order. That's my cat hanging out with the book. All right, and then I'm just going to take a small track to go through my typing experience and how I got into stenography. So I've been a layout switcher. I learned Dvorak as soon as I learned what it was. And I typed Dvorak for over a year. And then I switched to several other layouts as I kept trying to optimize to find what I thought was the best one. If anyone's curious, it's Norman. It's not a popular opinion. No, I went through Colmac. I did that for a year, and then Workman for a couple weeks. And then I did Norman, and then I've been doing that since. So I still use that alternative layout. And QWERTY. There's a place for everything. But a post on Hacker News came up talking about stenography, and I thought that was super cool. It sounded like a very fun thing to learn and would work very well with my layout switching habits. So the base entry for stenography, if you want to get into it, is just an N key rollover keyboard now. You can use the keyboard as the steno machine. You don't really need a dedicated machine. I had an Ergodox, which is a split mechanical keyboard, and I learned that you could actually program it with N key rollover. And so I did that and started to learn steno, and that was very fun. And then eventually through developing Plover, I've gotten this Trial steno machine, which was definitely better. And I've been writing, right now I'm hovering around 140 words per minute. I've been going at this for about 2 years. So I'm not making the same progress. Usually people graduate their 225 in 2 years, but I don't work all day trying to caption and make myself faster. I just use it as a keyboard replacement, and for that it works very well. Here's a graph of my type races on TypeRacer. So you can see my first successful race that I actually finished was 10 words per minute, and that was my speed for about a week. Now I'm up at, I don't know where it goes exactly, 140, 150, but it's come a long way. And so it's a very rewarding process, and you see waves where I switch machines and stuff. So how does Plover actually work? I hear the Pythonistas. There are 3 steps to the steno system that I have to deal with as the programmer, and it involves input from a hardware machine, and then some bag of logic and state, and then finally the output is simulated keystrokes, because that's what you need at the end of the day. This is some example of the hardware. So in the top left corner, you have an N key rollover keyboard. It's a gaming keyboard. On the top right, you have a breadboard machine that someone made for cheap. And then on the 2 bottom left keyboards are 3D printed ones that the community has made and open sourced as well. And the bottom right is the Infinity Ergonomic, which is the same machine that Mirabai uses in her own personal time. So the cost for these, the mechanical keyboard will run you about $80. The 3D printed machines are about $100 to $200. The Infinity Ergonomic runs between $3,000 and $5,000. And Charlie's homemade breadboard machine, priceless. So one of the big things about Plover that separates it from regular steno software is that you can just use a regular keyboard that has N-key rollover. And N-key rollover means you can press any amount of keys on the keyboard at once and they'll all register. Most USB keyboards are stuck around 6 keys at once. So in order to handle that, we need to block out the input from the steno keys and a few others that you'll hit accidentally if you're writing on it. And so you hit all the chords, and Plover stops that from going through, but records them, and when you release, it simulates its own output. Now, the biggest problem with that system is that it absolutely does block all keyboards on your system from working, because it's expecting input and then blocking it and then providing its own. And as a programmer, when I had a system like that running, if I was going to pair program with someone and they plug their computer into my machine, it wouldn't work that way. So if you have a real steno machine, that doesn't come up, which is nice. Then there's the logic bit of how the actual chording system works. And at the core of the theory is a JSON dictionary for Plover, which maps your strokes as key value pairs, where a set of strokes will correspond to some kind of string. So at the top there you have Pi Gotham, which is the translation. On the left, I have it in 3 strokes. Phonetically, it would be Pi, Goth, Am. You can also assign any sort of keyboard shortcuts modifiers. As you can see, I have Control-C there, which would just quit whatever I have in my terminal. And phonetically, I think of it as click or KLC. And then Plover has some special things to deal with regular English constructs like prefixes and suffixes, as you can see in Italy down there. And that's a suffix stroke, which uses regex rules to attach it to words in an intelligent way. So English has some rules in terms of when you add ly to the end of a word, if it already ends in L, well, you're going to end up with 2 L's in some cases. Sometimes you won't. And same goes with Italy, or even just Kli, but that's a whole nother story. And then the other thing that's involved, you'll see the entry for TED has a capital T, and that will literally be used when you write TED. It's always with a capital T. There's no lowercase TED, which is good for names, but then also you want to be able to control the case in certain cases. So down at the bottom, you can see a stroke for Mr., which has special syntax saying the next word should be capitalized after Mr. So if you wrote Mr. Dog, the D would automatically be capitalized. You don't have to think about that. You don't have to think about spacing. It's very nice, actually. And then you can see my programmer bit in there. I have a git push origin head refs for master. And I use that to push to Garrett code review. And the stroke phonetically is just git cr code review is how I remember it. And it outputs that whole string and then presses return to send the command right away. It's effectively a really big macro system. Finally, the output is the last step in the process. So you've got your hardware input, you know what the stenographer wants to do, and you just need to put it out. This is probably the most OS-specific portion of the code. You have to put out key presses. In xlib, in Linux, we use xlib, which works pretty well, and we deal with them all. Mac takes a little bit more than the others. So I'm going to list some kind of challenges that I've had to deal with, just as an idea of what the challenges are that come up on the different operating systems. On Linux, we had a problem where we weren't able to suppress the output that the QWERTY keyboard left. And so if you hit 6 keys, you'd actually get that jarbled output, and then Plover would backspace it and then write what you meant, which was kind of annoying to deal with, but luckily a super developer that I have, Benoit Pierre, fixed that. On Windows, when I started, the Windows key wasn't working, which I felt was slightly ironic. So I fixed that. It also had some problems where it wouldn't work in certain programs like Pigeon or 10 Fast Fingers, the website, due to underlying implementations. And so I just switched to which send keys I was using, and it works much better now. And then on OS X, it supports a string when you send a key code, And so I was sending key events with key code 0 and a character, and most programs could handle that. So you could send any arbitrary character. But when it came to legacy applications, it was looking for the key code, and all my text would just come out as lowercase a's. So that was a big problem too. These problems weren't really trivial to solve, and I think that the cross-platform output is now pretty good, such that we should probably pull it out into its own library. Another technical challenge that we have to deal with is multilingual Unicode, but that's not very interesting, so I prefer to use emojis all the time, and that will break your software, you'll find. And so if you want to test that you have good Unicode support, try going into all your web forms and insert emojis and see what happens. Enjoy. In Python 3, this isn't an issue, but we're not on Python 3. We're on Python 2.7, and mainly because of our UI framework being stuck there, which, again, super developer Benoit Piac has been rewriting the core of Plover so that it's Python 3 with a new UI that isn't so native. And our emojis work now. Basically, the bug manifested itself in the sense that the length of an emoji character is actually longer than your base letters. And so if I wrote the poop emoji, that would be a length of 2 in Python 2.7 on Windows and OS X. And so when you went to go backspace it with Plover, it would backspace twice and you'd get out of sync with your text output stream, which was awful. Similarly, if I tried to put out multiple emojis, Plover's kind of smart and it doesn't backspace more than it needs to, so it looks for common starts of the strings and only backspaces what's different. Well, all emojis start the same way, so it would try to backspace half the emoji and then output the other half, which crashed Safari on OS X. It's a pretty big issue, but now it knows that an emoji is only one character. So finally, I'm going to talk to you just a little bit about the future of stenography. There's still a lot of problems that, in my free time, haunt me. There are over 50 issues open on GitHub right now, and some of them are technical challenges. Some of them are dealing with internationalization. People want to steno in their own language. They want to be able to switch languages on the fly. These things don't exist yet, but it's a really fun challenge to kind of figure it out. I really love the Plover community because it doesn't just attract techies. It definitely doesn't just attract techies. We get people who don't speak much English. We get people who can't really use a computer, like debug their own problems. And so I get a lot of interesting bug reports. Sometimes it's because a button moved over. And that's a thing that I actually have to think about. And I like that as dealing with an open source project where you're dealing with people with different backgrounds. And I think everyone should try and experience that because it's a very human experience. We also have a really vibrant and interesting community. They're always trying to solve new problems. So recently we had people go through and look at the steno layout and say, this was made 100 years ago, before we had computers. We can make something better. And they threw dictionaries and logic and scripts and made jobs to lexicographically analyze English and try to find a more ideal layout. And so far their conclusion has been, let's just stick with it, which I'm glad for because I've spent 2 years learning it. So by now you might be wondering what the deal is. You know where stenos come from, you know how it works, and you know what it can do. But where's it going? Is court reporting still a real job? It's pretty valid questions and one that the Open Steno project definitely concerns itself with. So the Open Steno project is Mirabai's umbrella project for all of the things that I've mentioned today, all the free hardware, all the free software and learning resources, as well as the new games that have been coming out. It's a fun site, and I think for the future of stenography, it's going to grow in ways that I can't even imagine right now. People come up with ideas that court reporters, they don't need, you know? The technology has been made for transcription, and it's really, really good at that. But there are programming practices that we could apply to make steno so much more powerful. And I'm really excited for hackers and everyone to get their hands on it and make it better. For people like me, it's probably a little bit more selfish. I want to avoid RSI. I want to code. I want to type faster, and I want to be on the top of the leaderboards in Type Racer. I want to do it as a hobby, and I want to take notes more quickly. I feel like a lot of you guys might be in this category if you're curious. I totally welcome you to join us online. We're on opensteno.org. There's a Discord server. There's a lot of free stuff that you can get your hands on. It's super exciting, and as I said, Aloft.new is the captioning software that we've used. It was created by a self-taught stenographer, Stanley Sakai, who's working in that position right now. So thank you for your attention. Definitely, if anyone has any questions, I'm completely open to answer. Yeah?
So a lot of my family has dyslexia of some sort, and like specifically symbol recognition is like a huge issue for a lot of them. And so I'm wondering, has this software been tested out by that? Because you said a lot of it was about accessibility there too, and oftentimes it's also about spelling words out incredibly difficult.
Yeah. So I haven't met people who have dyslexia and who have tried the system, but it's definitely something that I've considered. A lot of people can think phonetically but can't translate that into spelling. I think there's definitely potential, and it becomes more muscle memory than actual memory as you learn to speak with your fingers. It feels more like talking when I'm writing on a steno machine than it does like thinking about the words that I'm trying to spell out. It's definitely something that I want to see someone with dyslexia try it and see what they can come out with. Because, yeah, you don't think about word order or anything like that. And it might manifest itself in different ways, but I'm not sure. It would be curious. Thanks. Any other questions? Yeah?
Just out of curiosity, why is use of stenographers at like open conferences, or is it that's not more common number of events?
So the question effectively was, why isn't steno used more for captioning conferences, being that it's so superior, right? Does that capture the essence? Okay. So definitely it should be, and I think that people should push for it. If you're at a conference that isn't captioning, maybe mention it to the organizers, because sometimes they don't know that they can do that. It really opens it up to more people. It helps create a transcript live so that when the videos go up, people who can't hear it can, still consume the content. It's a little bit expensive, but often you can get sponsored by companies that want this accessibility need to be filled. And the other thing is, the whole thing with this steno is that there's no amateur community. I am the amateur community, me and a few hundred other people. It's not like I mentioned piano, where there are way more amateurs than there are professional pianists. But that's how it should be with steno. There should be people just dipping their feet into it, and then you'll find the people who didn't know that this is what they wanted to do, and it pays very well. The other problem is that if you have a bad experience with captioning, you're going to remember that more than a good one. So Mirabai is very good at technical captioning, but a lot of court reporters might dip their toes into doing a tech conference, and that has never gone well when that happens, because you get all these weird terms. You get equal signs, underscores. You have commands. If someone says, LS or like Liz, they won't get that right. You should see at the word camp Stanley go, as he knows every single command line prompt that comes up. He just fills everything out as it comes in. It's very impressive. So I think it should be a thing, and definitely push for it, especially if you're hard of hearing, because you should be accommodated. Yeah?
So you mentioned that Plover and Moreover use the same word pattern.
Yeah.
How often do those conflicts come up, and how are they handled?
So conflicts are definitely a thing that people are aware of when you're writing, and there are lots of ways to disambiguate between the possible words. It comes up a lot with homophones, because you have bear and bear, as in bare naked, and a bear is attacking you while you're naked. So the difference there in the steno machine, you kind of just, there are certain rules. So that one's pretty easy to solve because hard A is written as AI. So if I was saying bare naked, that would be B hard AR. But the other one is EA. Often we use AE, just arbitrarily. There are lots of ways to deal with that, and some words that conflict, 3-4 times in a row. I think wave is one of them for me, or wait, that's it. Wait is spelled a lot of different ways, and you have to deal with that. There's also an asterisk key in the center of the board, and that's almost like your last case. All right, this is the common one, but if you add the asterisk, it's the uncommon version. So definitely ways to deal with it, and there are different theories as to how you should deal with it. Plover comes with a free theory that is encapsulated in 140,000 entries, but there are different ones that you can get into. Some of them are more strokes, but less conflicts, and some of them are really memorization heavy, where you can get full sentences out with just a single stroke. And those are super fast. That's that 360 words per minute guy that I was mentioning. He writes in a memory heavy theory. Question?
Yeah, so for the one where you use your normal keyboard, while you're learning, can you or just in general, can you just type out a normal word if you're I don't, or is it, since you're saying it's phonetic, to just try out stuff? Or
Yeah. So stenography itself has a way to spell out words letter by letter. It's a little slow, but you can toggle Plover with a stroke and turn it off and go back to regular writing. On OS X, you have to do that in password fields because they prevent key logging, and that stops Plover from working. So I'm out of time. I can't give any more questions, but I will hang out around with my steno machines if you want to see what they feel like. Try them out and ask any more questions you might have. You guys have been great. Thank you so much for being here. Steno machine? Awesome. I've done this talk before, and that's the hardest visual to get across. So, my goal today is to tell you about Plover, open source steno software written in Python. To do that, I need to define what stenography is and why its speed is so useful. I'll be able to convey in simple terms a little bit of the mental process that a stenographer has to go through when processing language. And I'm going to do that in a method that I like to call thinking with portals. We'll go over how Plover and OpenSteno came to be, and then talk a little bit about the Python program behind it. Finally, I'll close with some thoughts about where I think steno will go in the future. All right, so stenography is a system of writing that aims to decrease the amount of effort required to express language. You may have heard of common written stenography, written shorthand, like there's systems like Gregorian or Pitman, which court reporters used to use before steno machines existed to take down notes, as well as journalists before they typed everything or recorded it. With the written stenography, you could take notes pretty quickly, and a lot of students learned it too. It was basically before typing. It was the only way to write at that sort of speed, 80 words per minute or so. The stenography that I'm more interested in is machine stenography, and it's actually based off the same phonetic principles as written stenography. It's a system that optimizes for English, mainly phonetically, in order to increase the output speed of transcription. With machine stenography in particular, the stenograph allows you to chord keys. That means that instead of writing out the letters, you just medical startup called Clearwater Clinical. There I use JavaScript, mainly React and Redux, to build web applications for their products. I'm actually a really big fan of JavaScript, so all Pythonistas kind of hate me for that, but I don't hold it against you. I understand why Python is really great in its own way. I've used Python for what I consider a long time relative to my young age, but I've used it before Node was a thing, and so it was my first scripting language, my first language that I ran through a command line. And I used it for web scraping, little tasks, basically any sort of automation I did. I really liked it. I liked the duck typing. I like the named parameters. Best feature in any programming language. Use that all the time. So in my free time, I lead the development of an open source steno application called Plover. And I'm really lucky to work with people in the community who are smarter and more experienced than me, even especially with Python, and I've learned a lot from them. And I'm a software developer, clearly, and I use stenography and steno machines to program all my code. Steno machine, what's a steno machine? I've got a few up there. I have a few up here too in person that you can see. They kind of look like computer keyboards, at least in size, but maybe more like a piano or a musical keyboard. And that's definitely a little bit more how they play. So instead of hitting in individual keys to make a word come out, where you're spelling every single letter in order, instead you form your hands into a shape and push down on the machine and hit all the keys at once. And then when you release, that forms a chord. And accessibility video game company called For All to Play, and they partnered together and made Steno Arcade, which has a sub-game called Steno Hero, where you listen to songs and you type the lyrics in time with the singer to get a high score. So in my video, I'm writing on the Mac keyboard and the QWERTY layout, as well as my Trial Steno machine. And I recorded myself playing the song twice to get an idea to show the difference in hand effort. Pay attention to my fingers as the music is coming out, as well as the text output. Neither run was perfect. I was a little nervous and I didn't do very well, but you can still get a big idea of the difference between the two. So on the left, I'm not using any proper method to touch type. I'm not that good at QWERTY. I was just self-taught as a kid, and so my left hand, I'm left-handed, does a lot more work. And you can see that my hands are moving all over the keyboard, left and right. I'm falling behind. I was probably letting out a few expletives while doing the work. So on the right side, I've got the steno machine going, and you can tell that this is much slower than I'm capable of with the steno machine. I'm relaxing between words, just letting it out, waiting for the singer to let his words out, because I can see the text coming up. So there's a huge difference. Maybe now, is it clear to everyone how it looks to write on a... Like, super great, right? I've had fun. The only thing that I dislike is that I have to choose one of 4 talks, which makes me feel bad because I want to go to all of them. Too bad we're only here for 2 days. All right, so I've got a URL at the top of this slide up here, which is the same URL that I'm on that screen. So if you want to see the same view, you can. It should follow along as I go through on my own. So today I'm going to be talking to you about the technology that you see in that GIF there on the first screen, where there's my friend Stanley writing on a steno machine, and you can see he's writing into the same box that's at the top of the window, and it's outputting text. So I've got a Skype call running on my laptop right now, and on the other side is an individual named Mirabai Knight. Mirabai's kind of a strange name, but it is her name, and she's a real person. So please don't ask her if she's speech recognition software, because she isn't. She's much more accurate than speech recognition software is right now. And she's typing into a website called Aloft. Aloft is a captioning website that was made by Stanley, the guy who's writing in the picture. You can see we're a very tight-knit bunch. All right, so now I'm going to get started. Me, I'm Ted. Ted Morin. Morin Ted on Twitter and GitHub. I'm from Canada, Ottawa, Ontario, and I'm currently finishing up my software engineering undergraduate at the University of Ottawa. I split my time between school and working for a high-tech, the software outputs words. And this is what you see at the top of the screen right now. You can see every word comes out in one unit. And that's because Mirabai is chording her hands into make these words and little phrases. If I say of the should come out at the same time rather than individually, because common phrases are held together. So if I go of the, you'll see it comes out at the same time. It's really cool because you can kind of get some kind of, you can, all right, you can get some really long words out, like supercalifragilisticexpialidocious, with just one stroke. And you can basically apply that to anything. Instead of having a bunch of aliases in my bash RC, I have steno strokes that I can bring with me. So I've known about stenography for 2 years now, and I'm really excited to get a chance to share it with you guys today, especially if this is your first time hearing about it or seeing it in action. So stenography allows people to write on a computer over 225 words per minute, which is on par with human speech. And I'm here right now because Plover, the first free steno software, is written in Python. So before I get into the nitty-gritty of it, I'm actually going to show you a video so that you get a better understanding of what it looks like to write on a steno machine, because descriptions are only descriptions. I'm playing in this video a game that OpenSteno partnered with an